Okay, problem 7, we're going to solve perform some operations of complex numbers. This should not be too difficult for anyone. This problem, it says perform the indicated operations and simplify. It says simplify complex numbers. Simplify complex number will be of the form a plus bi. A plus bi is the standard form of complex numbers. So the first one is addition. So we will combine the terms, the real terms means the terms without I. So that is negative 25 plus 6 plus the terms with I, 8 plus 23 I. So when you perform this, this will be negative 19 I, negative 19 plus 31 I. The second problem is, this time is subtraction. So we will take the terms independent from I. So that is negative 25 minus 6 plus 8 minus 23 I. Combine the terms, so that's negative 31 minus 15I. Problem number 8. So that's the answer for the subtraction, and that's the answer for the addition. So the next problem is division of complex numbers. So you know that you need to find the conjugate of the denominator, and then you would multiply both the top complex number and the denominator by the conjugate of this denominator. So that's 9 plus 2i times 4 plus I, which is the conjugate of the denominator. So 4 minus I times 4 minus I times 4 plus I. We will use FOIL to simplify this. 9 times 4, 36. 9 times I plus 9i. 2i times 4, that's plus 8i. And then 2i times I is 2i squared. Over, that's a difference of, that's the product of the sum and the difference, which is the difference of squares. So that's 4 squared minus I squared. That's the product of the difference and the sum, which results to the difference of squares. Now we can go ahead and simplify. We will remember that I squared equals, you should remember that is negative 1. So we will use this as we simplify as well. So that is 36 plus 17i minus 2, because when you put I squared times, that's 2 times negative 1, right? And then over 4, that's 16 plus 1, because you have negative 1 times, that's times -1, which is +1. Okay, so that takes me to the last answer, that is 36/17. 36/17, not 36 actually, it's 34 because you subtract the 2. 34/17 plus 17/17i. Simplify, that is 2 plus I. And the next problem, the same number 8, but the second part of it is multiplication of these two complex numbers. So that is -14 times -12, that's +168. And then you got -14 times I, that's -14i. You got -10 times -12, that's +14i, because you have -14 times I. So -10i times -12, that's +120i. And then you have -10i times -I, that is +10i squared. We will combine like terms. 168 plus 120 plus 114, that's 134i, plus, actually that's -10. So your final answer for this operation will be 158 plus 134i. Okay, so next problem, number 9, will be for us to solve the quadratic equations. We started to go over them in class. Let's see how you would perform this. If you want, you can feel free to pause the video and try, and then play the video to see what you get. Subtract 12 on both sides. So that is 5x squared minus 17x minus 12 equals 0. So the quadratic equation, coefficient of x squared is not 1, so we would multiply 5 and -12. That's -60. Two factors of -60 that add up to -17 are -20 and +3. So we would try to rewrite this equation, this expression, as a 4-term expression, so we can factor by grouping. So that's 5x squared minus 20x plus 3x minus 12 equals 0. First group. And second group. The GCF of the first group is 5x. We factor it out. So that's x minus 4. And then the GCF of the second group is 3 plus 3 factored out. So that's x minus 4 equals 0. Then we factor this x minus 4 factor 5x plus 3 equals 0. We use the zero product property, so x minus 4 equals 0, which means x equals 4, or x 5x plus 3 equals 0, which means subtract 3 on both sides and divide by 5, x equals negative 3 over 5. Your solution set is 4 negative 3 over 5. There's no need for you to verify, but if you want to verify, you can feel free to do so. This is a two-term expression, quadratic. So we want to think about which way to factor this. Factor the GCF first. So that is 2p factored out. So that's 7p plus 11 equals 0. 7p plus 11 equals 0. This factor equals 0 and this one equals 0 using the zero product property. So that is 2p equals 0, or 7p plus 11 equals 0. Divide by 2, p equals 0. Or subtract 11 on both sides and divide by 7, p equals negative 11 over 7. Your solutions are 0, negative 11 over 7. Okay, so we're gonna look at the next problem, which is the number 11, which is a rational equation. So for a rational equation, you are always required to find the LCD, the least common denominator. In this case, your least common denominator is, pause the video and try to find it, 20. So we would multiply everything by 20. Then your new equation will be 20 divided by 5. That is 4. So 4 times x minus 9 equals 20 divided by 10. That's 2. So that's 6, plus 20 divided by 20 is 1. 1 times x minus 1 is x minus 1. Distribute 4. So that's 4x minus 36 equals 6, not 6. That's 5 plus x. So we would we group the x's and the constant on the other side. So that's 4x minus x equals 36 plus 5. So that's 3x equals 41. Divide by 3, x equals 41 over 3. Your solution set is 41 over 3. Next problem, number 12, says to solve this by using the square root property. So we would take the square root of both sides of this equation, plus or minus square root of this. Let me rewrite it. So that's square root of p minus 10 squared equals plus minus the square root of 6, and p minus 10 equals plus minus square root of 6. We would add 10 on both sides, so p equals positive 10 plus minus square root of 6. So your solution set is 10 minus square root of 6, 10 plus square root of 6. Number 13 says, consider the following equation. Solve the equation if multiple solutions exist, then enter the solutions using comma sign. If no solution exists, enter D and E, means do not exist. And so in this case, since you do not have linear term, which means the term with variable including the power 1, so we would try to isolate the t squared so we can use the square root property. So let's subtract 17 on both sides. 8t squared equals 8t squared equals 800, negative 800. We divide by 8. So we would have t squared equals negative 100. When we take the square root of both sides, that will be t squared equals plus or minus 10i, right? So that's t equals plus or minus 10i. And then we would have the solution set that is 10i negative 10i. Next problem, number 14, says solve the equation by the following equation using quadratic formula. So we would find the standard form, which is x squared plus minus 6x plus 72 equals 0. So we have a equals 1, b equals negative 6, and c equals 72. The quadratic formula that they say we should use is negative b plus or minus the square root of b squared minus 4ac over 2a. So x equals negative b is negative 6, so that's positive. B is negative 6, so negative b is positive 6, plus or minus the square root of b squared, so negative 6 squared minus 4, a is 1, c is 72, over 2 times the value of a, that is 1. We will simplify the expression inside of the square root first. You can type it into your calculator. Make sure you respect the signs. That should not be a problem. If you have a graphing calculator, you can just enter the exact same expression in the calculator, then you would have 6 plus or minus square root of negative 252 over 2. Now we want to simplify to see if the expression inside of the radical can be simplified, but we want to make sure that we use the complex, the imaginary property, so we can find the I value, because you know you cannot solve a radical with a square root with a negative sign inside of it if you don't use the imaginary property. So that is going to be an imaginary number, and then we would break down the value of this number. If you divide this number by the 252, if you divide it by 7, it will be 36 times 7. So this would be x equals 6, or you can break it down all the way to see what you can break this number, the 252, down by 2's and so on, and then group in order to find the value that goes on the outside of the radical and the value that goes inside. The value that goes on the outside will be 6. So that is 6 plus or minus 6i square root of 7 over 2. So divide by 2. So that's x equals 3 plus or minus 3i square root of 7. And then solution is 3 plus 3i square root of 7 and 3 minus 3i square root of 7. Next problem, we want to solve this by using the square root, the quadratic formula. A equals, it's already in standard form, so A equals 9, B equals -6, and C equals -7. So quadratic formula is x equals -b plus or minus square root of b squared minus 4ac over 2a. We replace the values. So x equals, b equals -6. So negative b is +6 plus or minus square root of -6 squared minus 4a is 9, c is -7 over 2a over 2 times the value of a, that is 9. Let's simplify. We will have x equals, we will simplify the value inside of the radical, that is, if you enter this in the calculator, that will be, let's see, what is it? Let's enter this in the calculator. That's -6 squared, -6 squared, minus 4 times minus 4 times 9 times -7. And then what do you get? It's 228. It's 228. So that's -6, I mean +6 plus or minus the square root of 288. If I said 228, I was wrong. So that's 288 over 18, which is the 2 times 9. So x equals, how do you simplify 228? If you divide by 2, let's see if we divide 288 by 2, that is 144. 144 is a perfect square. So if you take the square root of 144, that is 12. So that is going to be 6 plus or minus 12 square root of 2 over 18. And then everything is multiple of 3. We can divide by 3. So that is 2 plus or minus 4 square root of, oh, we can divide by 6 actually. So by 6, that is 1 plus or minus 2 square root of 2 over 3. So your solution set is 1 plus 2 square root of 2 over 3, and then 1 minus 2 square root of 2 over 3. That is your solution set. Next problem, it says to use this to solve this problem by completing the square. So if you want to solve this by completing the square, you want to make sure that constant is on the other side of your equation, and also you should divide each term of this equation by the coefficient of y squared, because when you use completing the square, your x squared or squared term should have a coefficient 1. So since the constant is already on the other side of the equation, now all I want to do is to divide everything by -6, which is the coefficient of y squared. So that is y squared plus 2y equals 8. So that said, we will try to find the third term that will complete the square. That completes this square. What is it? So it's going to be 2 divided by 2 squared. That equals 1. So that's plus 1 on both sides of this equation. So if you are asking me why I divide by 2 and square it, so that's a formula that says if I have x squared, x, let's say ax squared plus bx plus c equals 0, you would move the c over as your first step. Then you're going to be left and divide by a, and then you're going to be left with something that looks like this, -c, or just c because it's a number. And then to find the number that completes the square, you should add b over 2 squared. So this term, whatever it is, you divide it by 2 and then you square the value, and then you need to add it on both sides of this equation. So that's why I use 2 divided by 2 that is in the formula, and then square it to add it on both sides of the equation. This is 1. So after you add this on both sides of your equation, now you automatically have a perfect square on the left side of your equation. Now, how you write it in perfect square form? So this is 9. 8 plus 1 is 9. So you take the square root of the first term, that's y, because it cancels the y. You also take this sign, whatever it is. If it's a plus, you put plus. If it's a minus, you put minus. And then you take the square root of the final number, which is 1 in this case. So that's 1. And you automatically have your perfect square. Again, how you form your perfect square: square root of the first term, put it there. This sign, put it there. And then the square root of the last term, put it there. And the square is on the outside of the entire binomial that you find by doing this process. So then you have your expression in this form. You can take the square root of both sides. Y plus 1 squared square root equals plus or minus the square root of 9. And then that gives you y plus 1 equals plus or minus 3. Subtract 1 on both sides. Or let's say you have 2 solutions. Y plus 1 equals 3. Y plus 1 equals negative 3. And then you can subtract 1 on both sides. Y equals 2. Y equals negative 4. And those are your solution set. So that is negative 4 and positive 2. The next problem requires you to do the same thing, and the constant is already on the other side. Also, coefficient of y squared is 1. So things are easy for us. All we want to do is to find the third term that completes the square. So that is y minus 16y plus so we're going to put this and then find the third term. You know the third term is this number. You don't have to worry about the sign. You already know what to do with the sign when you complete the square. But over here, you need to take that number, divide by 2 and square. 16 divided by 2 is 8. Square is 64. We add 64 on both sides. So we will have y squared here. So that's y minus 8 squared equals 74. 74 is not a perfect square, and it doesn't have a factor that is a perfect square. So we would take the square root of both sides. No need to think about simplifying the 74 because it's not a perfect square and it has no factor that is a perfect square. So that is plus or minus square root of 74. So that's y minus 8 equals plus or minus square root of 74. And then your two solutions are y equals 8 plus square root of 74 and y equals 8 minus square root of 74. So your solution set 8 plus square root of 74, 8 minus square root of 74. Our next problems is number 18. We want to solve the polynomial. And how many solutions we have, we will separate them by a comma sign. So let's make sure that we zero this equation out. We would add 40 on both sides. So that is x to the third minus 10x squared minus 4x minus plus 40 equals 0. It's a four-term expression. And I always say, whenever you have a four-term expression, you want to see if it's possible for you to factor by grouping. Let's find this one, this first group and the second group. GCF of the first group is x squared. Factor it out. That's x minus 10. GCF of the second group is negative 4. Factor it out. So that is x plus. So that is a plus 40. Okay. So that's plus 40. And then that is x minus 10 equals 0. We refactor this, x minus 10 factor x squared minus 4. This can be seen as a difference of squares. We can refactor it. So that's x minus 10, x minus 2, x plus 2 equals 0. We want to use the zero product property. X minus 10 equals 0. X minus 2 equals 0. X plus 2 equals 0. So that says x equals 10 is one solution. X equals 2 is another solution. And x equals negative 2 is the third solution. So that makes the solution set 10, 2, negative 2. Okay. So next problem is the same type. We are trying to solve this equation and try to make sure that we separate when we get the solution, we separate the list of solution by a comma sign, which is usually what we do, right? So this equation is already, all the terms are already in, on one side and 0 on the other side, which is good, and it's a four-term expression. We can try to see if we can factor by grouping. So if we group the first two terms, group the second pair of terms, and the GCF of the first group would be x to the second, and then 6x minus 5. GCF of the second group will just be 1. And then 6x minus 1 equals 0. Minus 5 equals 0. And then we can refactor the 6x minus 5. It's x squared plus 1 equals 0. So apply the zero product property, 6x minus 5 equals 0, or x squared plus 1 equals 0. X squared plus 1 cannot be solved as an equation in the set of real numbers only because you cannot square a number and plus with a positive number for this to be 0. So that's going to be complex, but that's fine. Just wanted to point that out. So if you add 5 on both sides, 6x equals 5, and divide by 6, x equals 5 over 6. And then over here, x squared would be -1. If you take the square root of both sides, x equals plus minus square root of -1. And then you all know that square root of -1 equals I being the complex imaginary. So x equals plus or minus I. Your solution set is 5 over 6, -I, and +I. This next problem is the same as number 19, so we can skip it. Let's move to number 21. Number 21 is the same thing that we did from number 19 and 18. We can just continue the same process. So we would find all the terms on one side. So that's 5x. That is let's find everything on the same side. So we would subtract 20x and add 16 on both sides. So that is 5x to the third minus 20x squared minus 4x squared minus 4x squared minus 20x plus 16 equals 0. First group and second group, GCF of the first group is x squared, 5x minus 4, -20, -4 is the GCF of the second group. So that's 5x minus 4 equals 0. We factor 5x minus 4. So that's x squared minus 4 here on the second one. And then you can refactor x squared plus minus 4 as difference of squares. So that's 5x minus 4, x minus 2, x plus 2 equals 0. So 5x minus 4 equals 0, x minus 2 equals 0, x plus 2 equals 0. X equals 4/5, x equals 2, x equals -2. Solution set 4/5, 2, -2. Next problem, you would be using a change of variables to set this equation up and then go back to your original variable. So if I call x equals square root of k here, so that I can remove that square root in my equation, and by squaring both sides, I would have x squared equals k, because the square cancels the radical. And then I'm gonna go back to my equation with x instead of square root of k, and x squared instead of k. My new equation becomes x squared minus 4x minus 21 equals 0. I can find two factors of negative 20 that add up to negative 4. Think of it. So the two factors are negative 7 and positive 21. So that's x minus 7, x plus 21. Plus 3 equals 0. So if I use the zero product property, that's x plus minus 7 equals 0, or x plus 3 equals 0. Solving this, x equals 7, x equals negative 3. Now we need to pay attention to whenever we get to this point. Because when you get to this point, you have the tendency to think that, oh, that's my solution, and forget that we changed the variable to set up the equation. So whenever we get these answers, we need to go back to our previous variable, so we can continue to solve the equation. So we have x that was square root of k. So we would need to replace square root of k equals 7. But the second situation is negative. Square root cannot be negative. Square root is never negative. Square root of a number will never be negative. So just like absolute value. So that means this is rejected. Whenever you get to a point where you are solving an equation, square root of a number equals negative number, that cannot be, this is impossible, because the square root of a real number is always positive. So that means the only solution we will find is from x equals 7. Now, if you square both sides, you will get k equals 49. And then 49 is your only solution for this equation. For your next problem, you're going to do the same thing, but every time you see those situations, you may want to think about what type of change of variables that you need to do in order to allow you to solve this problem. Just like we're looking at, you see how instead of x squared, we have x 2 over 3. And then instead of x exponent 1, we have an x with an exponent 1 over 3. Now, I think the change of variable that we want to do that will allow us to find the regular quadratic equation that we use to solve would be if we call x exponent 1/3 equals y, for example. Now, by calling this, you would have x exponent 2/3 by squaring both sides equals y squared. That said, we will be able to have a better situation with a y variable for our equation. So that is y squared instead of x exponent 2/3 plus y instead of x exponent 1/3, and then we can move the 72 over. So then that's the new equation we have. Like I always say, never forget to return to your previous variable whenever you finish solving for y. So this, we can factor this. That's an easy factor, because 72 negative 72 is positive 9 times negative 8. If you say negative 9, then you would expect a coefficient -1 for y. That's not going to be right. You need to find a +1 coefficient for y. Then you need 9 to be positive and 8 to be negative. So that's y plus 9, y minus 8 equals 0. The zero product property, so y plus 9 equals 0, or y minus 8 equals 0. So two solutions, y equals -9, y equals +8. And then now we can go back to the change of variables we had at the beginning, which is x to the third, which is x being the previous variable. That's what we're solving for, equals y. So that is x exponent 1/3 equals -9, and x exponent 1/3 equals +8. And now, if we want to solve for x, we want to raise both sides of these equations, x exponent 1/3 to the power 3, so that we'll cancel the fraction 1/3. We got x by itself, but if we do it on the x side, we must do it on the y, on the -9 side. Same thing here. So that is same thing for this, the second equation. So that is x exponent 1/3 to the third equals 8 exponent 3. So your answer will be x equals -729, and then x equals 512. Your solution set -729 and 512. Okay. Next, we will do the same thing. Let's call x to the 1/3 power equals y. So that means x 2/3 equals y squared. So that's 4y squared plus y equal -3 equals 0. So we can multiply 4 and -3. That is -12. Two factors of -12 that add up to the coefficient of y1 positive. So that's 4 times -3. And then that's 4y squared. We're going to write this equation as a 4-term expression on the left side, so we can factor by grouping, right? So that is 4y squared plus 4y minus 3y minus 3 equals 0. By grouping, first group, GCF is 4y, so that's y plus 1. And then GCF of the second group is negative 3, so y plus 1 equals 0. We can refactor this as y plus 1 factor 4y minus 3 equals 0. And then we would have y plus 1 equals 0, or 4y minus 3 equals 0. First one, y equals 1, or the second one, y equals 3/4, right? And then, oh, negative 1 over here, sorry, because we subtract 1 on both sides. And then we go back to our previous variable, that is x. So that's x to the third to the first to the 1/3 power equals negative 1. And that's, if you raise both sides to the power 3, that cancels the power 1/3. So that's x exponent 1/3 to the third power, negative 1 to the third, so x equals negative 1. And the second one, same thing, y x to the 1/3 power equals 3/4. Raise both sides to the power 3, that cancels the power 1/3. So that's x equals 27 over 64. Your solution set is negative 1, 27 over 64. Okay. Next, number 25 is where you want to solve an equation that involves radical, more specifically square root. Whenever you have that, you must, and in this case is it's the radical equation for us. So you must always check for your solution, because there may be some extraneous solution. So extraneous solution is solutions that you solve the equation and found, but when you replace them in your equation, they don't verify your original equation. So that's when you call the solution an extraneous solution, which means a solution that does not verify. So it's not a real solution, or it's not a viable solution for your equation. So you don't keep it. How do you solve a radical equation, a square root equation? Well, you first isolate the square root part of your equation, and then cancel the square root by raising both sides of your equation to the second power. Like when I say second power, it's because it's a square root in this case. If it's another root, then you would raise it to the power equal to the root or index of your radical. Let's get started. This case, it's already isolated. Then you can just raise both sides to the second power. So that's x squared equals 8 plus 7x, because the square cancels the radical, so you have an equation that has no radical anymore. then since you have a square, right, you will think of a quadratic equation, right? So when solving a quadratic equation, you may, unless you are solving it by completing the square, you need to have all the terms on one side and then find out if you can factor or using the quadratic formula. If they say solve the quadratic equation by completing the square, then you would need to do otherwise, or if you are solving by radical, by the square root property. Otherwise, you always want to find the standard form, use the quadratic formula, or you can also use factoring method. So let's move everything on one side. So that's x squared minus 7x minus 8 equals 0. You can see that this thing can be solved by factoring. So two numbers multiply to give you -8 and add to -7. You say -8 and +1. So that's x plus 1, x minus 8 equals 0. The zero product property, x plus 1 equals 0. Or x minus 8 equals 0. And then solve x equals -1 and x equals +8. So we want to check for each of these solutions. You should check. You must check. So that's -1 equals square root of 8 square root of 8 plus 7 times -1. So that is -1 equals square root of 8 minus 7. -1 equals square root of 1. -1 equals 1. That is false. So -1 is to be rejected. Because it does not verify your solution. So it's an extraneous solution. It does not verify your original equation. Let's see what happens for 8. So that's 8 equals, we place x by 8 in your previous equation. 8 equals square root of 8 plus 7 times 8. It's 8 plus 7 times 8. So what do you have here? It's going to be 8 equals square root of 8 plus 8 plus 56, right? And then that's 8 equals square root of 864. And then 8 equals 8, checks. So your solution is 8. Your solution is 8. In this case, your equation, and by the way, 26 and 27 are the same, so we will skip 27. So 26, we want to isolate this part of the equation. So we get it by itself. We start this by adding 1 on both sides. And then and then we can keep this square root of x plus 7. Or if you want to square it, if you want to divide by 2, feel free to do it, but you're gonna have to undo the denominator again. So that's why I'm gonna keep it on this side. And then raise both sides to the power 2, so you can cancel the radical. So that is 4 times x plus 7 equals 1 minus 2x plus x squared. And then now we can distribute and move everything to the same side. So that's x squared minus 2x plus 1 minus 4x minus 28 equals 0. Yes, x squared minus 2x plus 1 minus 4x minus 28 equals 0. So then combine like terms, x squared minus 6x minus 27 equals 0. Then we can factor by grouping, but not by grouping. We can factor by finding two factors of negative 27 that add up to negative 6. Think of it. So that's x minus 9 times x plus 3 equals 0. X equals 9, x minus 9 equals 0, or x plus 3 equals 0. So two solutions, x equals 9, x equals negative 3. So we want to check this to make sure it works. So that's, for the first one, it will be 2 square root of 9 plus 7 minus 1 equals 9. So that's 2 square root of 9 plus 7 is 16 minus 1 equals 9. So that's 2 times 4, square root of 16 is 4, minus 1 equals 9. 8 minus 1, that's 7, equals 9, that is false. So x equals 9 is rejected. So that is rejected. So let's check to see how it works for the second one. That's 2 square root of negative 3 plus 7 minus 1 equals 9. 2 square root of 4, which is negative 3 plus 7, 4, minus 1 equals not 9, but negative 3. Negative 3. Is it negative 3? Yes. So that is 2 times 2 minus 1 equals negative 3. So that is 4 minus 1 equals negative 3. 3 equals negative 3. That is also false. Let me check to make sure. Yeah, that's also false. So that means there is no solution for this. That also is rejected. This negative 3 is also rejected. So we have no solution for this equation. So that's a D and E. There's no solution. Well, that is there was a mistake here. It's not no solution, because when you replace -3, we would say that should be a +3, right? Because you need to replace -3 here. And then when you replace -3, -3 is a +3. So then that should be plus, 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 and plus. So that is true. And that is not rejected. That makes your solution is -3. So solution is -3. All right. The next problem is the same type. So we want to subtract 9 on both sides. Square root of -3x plus 27 equals x minus 9. Raise both sides to the power 2. -3x plus 27 equals x squared minus 18x plus 81. And then we will move everything on the same side. X squared minus 18x plus 3x plus 81 minus 27 equals 0. Right? And then that will take us to x squared minus 15x plus 54 equals 0. The fact, two numbers that multiply to give you 54 and subtract for -15 are -6 and -6 -6 and +9 and -9, both of them negative. So that is x -6 times x plus -6 minus 9 equals 0. The zero product property, x minus 6 equals 0, or x minus 9 equals 0. So x equals 6 or x equals 9. Check them. Square root of -3 times 6 plus 27 plus 9 on the outside of the radical. Is it 6? We'll see, right? So that is square root of 18, -18 plus 27 -18 plus 27 is 9. So that is square root of 9 plus 9. Is it 6? So that's 3 plus 9. Is it 6? That's 12. That is not 6. So -6 is rejected. x equals 6 is rejected. And then let's check for x equals 9. We will replace -3 times 9 plus 27 plus 9. Is it 9? Well, that's 0, square root of 0, because -3 times 9 is -27 plus 27 is 0. Plus 9 equals 9. So 9 equals 9, checks. So your solution is 9. Now we transition to solving absolute value equations. Well, absolute value equations requires one of the things that we did for radical equations, because since absolute value of a number is always positive, so whenever you're solving an absolute value equation, you need to make considerations. First thing is that you need to isolate the absolute value part of your equation, and then set up two conditions. The expression inside of the absolute value equals to the number on the other side if it's not negative, and also consider the expression inside of the absolute value equals to the number on the other side negative, but it's only if it's positive. Because if you have an equation like this, absolute value of expression, whatever the expression it is, if it equals a negative number, well, you don't have to do anything more. That equation will not have a solution, because by definition, absolute value, result of the absolute value must be negative. Well, you can solve and find a negative answer for your variable, but once the absolute value of an expression is equal to, by itself, to a negative number, then this equation has no solution. Keep that in mind. Now let's isolate this absolute value. Subtract 2 on both sides. That's 3 absolute value of c minus 5 equals 12. Then we divide by 3. Absolute value of c minus 5 equals 4. Positive. Now we're going to create the two cases. C minus 5 equals 4. C minus 5 equals -4. See? Set it up like this. Always positive and negative on the other side, but it's the same expression that is inside of the absolute value that equals to both of positive and negative of the number on the other side. Well, we can solve now by adding 5 on both sides. C equals 9. And add 5 on both sides. C equals 1. And then we don't need to check. If you check, it's not going to hurt, but if you make sure that the work is done well, so you can just give your answer without checking. Just like, but in the equation, radical equation, checking is required. Do the same thing here. We will subtract 8 on both sides. -4 absolute value of -5x minus 5 equals -24. Divide by -4. Positive 24. Divide by -4. Absolute value of -5x minus 5 equals -6. So that's a problem. That's the problem we were talking about. Absolute value of expression equals -4, -6. So we can make the conclusion that this equation has no solution because by definition, the absolute value of an expression must be positive. Must be positive. So if it's negative, then this equation will not have a solution. Next problem is to solve the same thing. Then we will go over the same, we will go do the same thing, -1 on both sides. -9 absolute value of negative 14 plus 7/12 equals 9. And then what? We will divide by -9. Absolute value of -14 plus 7/12 equals -1. No solution, and you know why already, because absolute value of expression must always be positive. No solution. Next problems will be about solving inequalities. Well, solving inequalities, you have you may be asked to graph the solution on the number line and to give the answer in intervals notation. So both of them may be something that you need to pay attention to, because you may be asked to give both in some equations as well. So when you're solving inequalities, it's not very different from solving equation, because you're going to use all the properties, but the solutions are going to be intervals, because it's not going to be one single solution, since the statement is going to be to cover an entire interval. So let's get started by adding 50 on both sides. -5x greater or equal to 25. We subtract 25. So we divide by -5. So when you divide or multiply by a negative number, that switches the sign of the direction of the inequality. So that takes me to x less than or equal to -5. Well, on the number line, because you have less than or equal, you're gonna need a closed circle on your number line at the number -5. So closed circle, right? A closed circle, right? And then it's less than or equal, so the solution will cover everything less than 5, including 5. I mean -5. So everything less than 5, including -5. And you know, when it passes -5, it goes all the way to -infinity. So your interval notation will be, you always read your solutions on the number line from left to right. So from -infinity to -5, with a closed circle, you put a bracket on the value, on the value, but infinity will always take a parenthesis. But if it's a closed circle, or you have or equal, like that means including the value, then you will need to keep a bracket. In this case, you're not going to keep a bracket on the number, because it's not included. With no equal sign, it's not included. So you would put parentheses both on infinity and the number. Let's distribute the value here, to cancel the parentheses. So that's negative. Oh, well, what we can do too is that we can divide everything by -3, right? Because since it's everything is it can be divided by -3, so it will be better if you clear it. You would get numbers that are smaller, less chance for you to make mistakes. So we divide both sides by -3. So that's 18 minus W, since we divided by negative number. So we swap the inequality to greater than. That is 2 minus 3W. So if we add 3W on both sides, that will take me to 18 plus 2W greater than 2. And then we can subtract 18 on both sides. You would get 2W equals -16. I mean, not equals. You know what it is. It's greater than. And then we divide by 2. Then answer would be W greater than -8. W greater than -8. W greater than -8. So if W is greater than -8, that is a non-included inequality. So that will be an open circle on -8, and it goes to the right because everything beyond -8 on the right would be solution, but not included -8 because it was greater than, simple or strict greater than. It goes all the way to infinity. So my interval form of the solution, that's the graph, but the interval form would be -8 to infinity. Parentheses for each because -8 is not included, and on infinity, you are required to keep a parenthesis. This is a compound inequality which requires you to solve multiple inequality at the same time. So in this case, it's easy because you can just keep the x alone by itself in between the inequality by performing inside out operations to clear the side of x. So we can start adding 4 on each part of your inequality, compound inequality. We adding 4. So that is 28 negative less than or equal to 4x less than 20. Then if you divide by 4 everything, -7 less than or equal to x less than 5 would be what's left. Over here, you have less than or equal. So on 7, we're going to keep a closed circle. And then on 5, it's not equal. Then we will keep an open circle. And everything inside the 2 circles will be your solution for this inequality. So your interval notation, this is a bracket because it has a closed circle, and this will be parenthesis because it has an open circle. So that's bracket -7 and 5 with a parenthesis. When solving a quadratic, when solving absolute value inequality, it's like compound inequalities. Compound inequalities. If you have absolute value of A less than or equal, right? Number, so you can do it two ways. You can set up A without the absolute value, less than the number, and then A is greater than the negative of the number. Or how you can see it is the expression inside of the absolute value must be less than the number. So you keep everything, you just drop the absolute value to create case 1. And then the second case, case number 2, is the case where you drop the absolute value, you swap the inequality, and you change the sign of the number on the other side. Let me say that again. Drop the absolute value, change the inequality sign, flip the inequality, and change the sign of the of the number. So drop, change, or drop, flip, change. Drop the absolute value, flip the inequality, and then change the sign of the number on the other side. So drop the absolute value, I write A. The inequality was less than, I change it to greater than. The number, and you change the sign to negative sign. So with the two cases, then you can solve the inequality, both of them, and graph them just like, or give the solution in interval notation. Well, if it's the other inequality, if you have absolute value of A greater than number, do the same thing. Case 1, you drop the absolute value, so A greater than number. And then case 2, you would drop the absolute value, A, you flip the sign, and then you flip the inequality sign, and you change the sign of the number to solve the inequality. And then you solve both of them, and it gives you the answer. Okay, so that said, we will perform what we just said. So first, we must isolate the absolute value. Let's subtract 16 on both sides. -9, absolute value 5x plus 7 is greater than -3. Divide by -9. Absolute value of 5x plus 7 is greater than 1/3. So let's create the two cases. First one, 5x well, we divided by -9, so that should be less than, because you swap the sign. So that's 5x. I like when I keep the inequality as one group. So that's 5x plus 7. That is less than 1/3. That is greater than -1/3. Or if you create the two cases, it's not going to make any difference. So I love this form more than the other one. That's why I use that one instead. So what do you do next? You subtract 7 on both sides. So that's -1/3 plus, minus 7 less than 5x less than 1/3 minus 7. So that is negative 22 over 3 less than 5x less than negative 20 over 3. Right? And then let's divide by 5 everything. So you know when you divide a fraction by another fraction is to multiply the first one by the second one reciprocal, by the reciprocal of the second. So that's negative 22 over 15 when we multiply, less than x, less than, so that would be negative 20 over 3 times 1/5, and then simplify by 5, that's negative 4, so negative 4/3. Well, negative 4/3, so that's the answer. In interval notation, since you have strict inequalities, you would keep parentheses for your values. So your solution will be negative 22 15ths and negative 4/3 parentheses. So next problem, absolute value. We want to do it the same way. We can add 5 on both sides, and then 5 absolute value of 6x minus 1 is greater or equal to 6. Divide by 5. Absolute value of 6x minus 1 greater than 6/5. And then you can set up this as 6x minus 1 greater than 6/5. And then that's case 1. The other one would be 6x minus 1 is less than negative 6 over 5, right? It's greater than or equal, and then that's greater than or greater than or equal. Yes. Okay. And then now let's solve them each. So 6x minus 1 greater than or equal 6 over 5. Let's add 1. So that's 6x greater than or equal to 11 over 5. Divide by 6. So that is x greater than or equal to 11 over 30. Okay? And then the other case, that's case 1. That's case number 1. Case number 2 would be 6x minus 1 less than or equal negative 6 over 5. We would add 1 on both sides. Add 1 on both sides. 6x less than or equal to negative 1 over 5. Divide by 6. X equals negative 1 over 30. Not equal, that's less than or equal. Less than or equal. Let me show you this these two inequalities on the number line. That is 0. Negative 1/3 will be on the negative 1/30 would be on the left side. Let me put it here because it's very small. So that's negative 1/30. We would need a closed circle for it. Positive 11/30 will be small, but not too small. So here, positive 11/30, it would need a closed circle as well. And you know that x was smaller than negative 1/30. So that means left side. So the left side will be what we shade for the solution here. And then the x is greater than 11/30. So that'd be this side of solution. So negative infinity over here and positive infinity. So your solution will look like negative infinity to negative 1/30 with a bracket, union, bracket, 11/30 to infinity. That is your solution set for this inequality. And number 36, same thing. We can just set up this inequality however we want it to be, but that's going to be easy. It's already isolated. So but I like when it's the expression inside, which is 2x minus 6 less than the number on the other side. Whenever it's less than, I want to keep it this way. It's simpler. 18 and less than or equal to negative 18. So positive 18, negative 18 on both sides. And then add 6 on each side and add 6. So 2x less than 24 and 2x is greater than or equal to negative 14. If I divide by 2, that will give me negative 7 less than or equal to x less than or equal to 12. Okay, so let's find these values. We're going to put closed circle because we have included sign. So that is negative 7, closed circle, positive 12, closed circle, and then in between will be your solution. In between will be your solution. So that is this for your solution. So my computer is dying. Let me put the charger. Perfect. Okay. So with that, you have your solution that is bracket negative 7 to 12 with a bracket as well. Okay, number 37. Number 37, let's see. Same thing, right? But you're gonna create the two cases. First case is x minus 4 is greater than 3. Second case, x minus 4 less than negative 3. Switch, right? Switch the sign, switch the inequality. Add 4 x greater than 7, add 4x less than 1. Find them on the number line with open circle because you have no equal sign for the inequality. So that is 7 with a open circle and 1 with an open circle. Oops. Your solution will be, that's number 37, right? So your solution will be everything on the outside, because one solution x, which all the solutions will be less than the value 1. So from negative infinity to this value. And then all the solution will be also greater than 7, greater than 7. So your solution will be from negative infinity to 1 with a parenthesis union, from 7 to infinity, from 7 to positive infinity, is the solution for number 37. So that we've used all type of problems you need to expect from chapter 2 on your test. Please make sure you review the videos and then take your practice problem on My Open Math and get 85% or better to get extra point added on your test. But if you don't review that, you have a chance to not do so well on the practice, consequently not do so well on your test. I will see you next class.